makes me think, what are some of the most difficult substrates you've had to deal with in regard to overmolding? Not just electronics, maybe a small needle with a sharp point or a wire or a tube, or do you have anything in mind?
Yeah, the first one that comes to mind is a gold-plated anything. Nothing sticks to gold. So not thermoplastics, not adhesives. It's really hard to seal against that. So that has to be a consideration. If we have an exposed gold surface and the electronics are in the inside, and getting that to seal is probably going to require another operation. And that's where the elastomers come in. The elastomers can provide that seal around the gold to keep liquids or moistures from coming in. And then the sensitive materials. We had a customer with a few really sensitive components where we had to shift our gates around to keep them from getting damaged. But we've always found supporting those components and locking them into the mold to support them is absolutely critical. And that enables the overmolding of some pretty fine components. We have overmolded tiny wires that are 200 microns in diameter. Not so hard overmolding, but getting them into the mold and holding them in place while the plastic is injected around them, that's the trick.
That is.
And then we would measure position repeatability, retention force. How can that replace, say, a manual insertion or a post-molding insertion process where glues or adhesives or some other method to hold those components in places are needed. If you overmold it, a lot of times the plastic will lock on it and eliminate any post-processing for that.
Yeah, definitely. So I'll jump back into that conversation there, Jeff, in a second here. But the question we had, how thin/small can you go, and what kind of material lends itself to the smaller features versus larger parts? So very, very common questions. Typically, when we're talking wall thickness, we've molded wall thicknesses down to just 0.02 of an inch. Like I said, we've molded sharp points on things as well. So we can go extremely thin, extremely small. Materials, polycarbonates, polypropylene, mold a lot of LSR, which probably gives you the most capability when it comes to thin features. But LCPs is very common. There's some very high flow peaks that we actually do with some high density connectors that we've been very successful with, flowing around a lot of small features and doing some extremely thin walls with some of those high flow peaks. There's also some Ultems that work very well too. So I think high temperature resistance applications. There's some medical grades that we use for a lot of things too. Lots of different materials we can work with. Typically what we like to do is just work with our customers on the front end, see what their characteristics are they're looking for. And generally, just given our amount of experience we have looking at other designs and molding parts in the past, we can usually point you in the right direction with a couple suggestions and go from there.
Yeah, and I think one thing the DFM team has done is not just looked at the single component, but taken on the whole device, if allowed, by our customers to look at the whole device and how the different components are interacting and come up with creative solutions for not just manufacturability, but even functionality and such.